No, I was watching a compilation last night. One of the funniest things that stood out to me was Great Wall of China. Look out for them. No one's gotten through it. Oh, what?
Connor, I told you they're too close.
No,
No.
it's gonna be huge, Tyler.
It's gonna be huge.
It's gonna be huge.
It's gonna be huge. It's gonna be great. Stu, that new dude just suits you.
Snooze do.
Stu's dude is good.
Snooze do.
The undergrain happened to him.
No, I died yesterday in American History when Trump came on. That was just...
Wait, what happened to
Trump came on.
Oh, yeah.
Yes. That was so funny, honestly.
I was like, man, that's gonna be the president of the United States. That's what I said.
Well, that is
Oh, he just took my breath away. Is what he did.
Connor, you're fired.
Alright, I'll just build a new job.
Doesn't Donald Trump just take your breath away?
Let's just build a new job.
I'll just build a new job. And you know what?
That's a terrific idea.
Then the legals won't be able to get into it.
So did you do that?
This?
Yeah.
This right here?
Yeah.
No, what is that?
I know. And then the project here, I opened it. I was skin, baby.
I think I give up. I think I threw.
That's that.
I'm very stressed.
With.
This is all the legals can build up.
They got Subway?
I'm done.
No.
Oh.
Okay. Alright. Okay, today we're gonna do a couple more problems on these story problems, kind of problem solving with these quadratics. I'm gonna do just a few more problems today. We'll kind of start with an easy one, kind of work our way to kind of a more difficult looking problem, something that takes a little more skill. That's what I'm gonna look at today. And then we will get a little bit of work. That'll be later this week. So it's pretty straightforward. I'm not saying a lot of problems because if you've been paying attention the last couple days, you've been taking some notes, you'll be fine. It's basically going to give you some bigger problems too. Okay, so again, we're under polynomial rational functions. This is kind of our idea here. And what we're doing is we're trying to problem solve, right? So we're trying to look at how to take a quadratic, completing the square, and showing like what that can do for you. So problem solving and practical application. Okay, so does everyone kind of understand like what we've been going through the last couple days?
Haley Crowder, please come to the office. Haley Crowder.
All right. So for the first couple of problems, 63, 64 in that range in the book, this is the type of problem that they're giving you. Okay, they're going to give you some type of problem where it's just based on numerical differences. It's a number theory problem. It's not really a story problem, but there is a method to approaching this problem. Okay, so pairs of numbers who differ by whose difference is 20. So you can think of numbers that differ by 20, like 20 and 40, or 10 and 30, right? So numbers that differ by 20. I need the pair that will give me the product. Their product is as small as possible. The smallest product you can make with two numbers that differ by 20. Okay? So the setup is, if you don't know the first number, give it a variable. Right? So that's your first number. Now, what would the second number be? This is the main thing that we need to understand for this problem. What will the second number be compared to x? X minus 20. Okay? That's the idea. They can differ by 20 like this. Now, if you're in that mode where it was like 20 minus x, what you're doing is you're basically finding a sum that would give you 20. 20 minus x is like when the two numbers have to add up will give you 20. So there's a difference there. So that's just something you need to kind of realize for that. I could have put x plus 20 there because I could add 20 to it or subtract. I usually do subtractions because I'm trying to find a difference kind of thing, but it's not a big deal. All right, so these are my two numbers. I need to find the product of them, and that'll be my y number. Okay, so I'm finding the product. That is my function. But I need to find the product, and I'm trying to find the number that is small as possible. The product is small. Okay, so when we do this problem, we distribute. So that's x squared minus 20x. And the good news is on this problem, I don't need to rearrange. It's already in, already in descending order. There's no digits to drag over to the y side, so now I can complete the square right where it's at. There's no number in front of the x squared, so I don't need to factor out anything. It's like yesterday, I think we did a problem where there was like a -1 out front. This problem doesn't have any number. It's just a 1 sitting there, so I don't need to really factor anything. So I can just do half the middle. So half the middle number, 10 squared, 100, and that's when I add to both sides. Now why I'm adding this to both sides is because you're taking the number 100 times whatever was out front, and that's putting over. That's the idea. Well, there's no number out front. It was a 1. It's no big deal. So now on the left side, I can actually factor that apart, or the right side. So this left side just stays, you know, the y equals 100, but this right side here, this actually turns out to be x minus 10. And how I know that is it's a trinomial, right? So it's going to be 2 parentheses, it's going to be minus minus because they're both the same operation. This tells you that they have to be the same, and you just break this up evenly. Well, it's just the shortcut is half the middle. That's how we made it. So that's the way that I've basically done every problem so far. And so now, what's my vertex on this particular problem? 10, negative 100, right? Because it's always the number. It's always the opposite with the x, opposite with the y. This is your first number of the pair. It's your first number of the pair. And this is the smallest product you can get. This is the smallest product. So it's actually giving you both answers. Now the only thing it doesn't give you is the other number for the pair. It gives me the first number. This is, this number is 10 here. So what would the other number be? Negative 10, because it's 10 minus 20. There's the other number. And the smallest pair, or the smallest product you get is negative 100. Because if I pick any other numbers, that product will always be bigger than that. So if I pick, 5, so 5 and negative 15, that number is not going to be smaller than negative 100. Okay, it's going to actually be a little bit higher than that. Okay, questions, comments?
Okay, so the first problem you did was 5 and negative 5, and then the second one was 6 and negative 6, and this one's 10 and negative 10.
Yes.
Is that, that's something that's going to happen consistently? Or?
No. It just happen to be the numbers I'm picking, because I'm basically giving you the same story problem and stuff, so not really.
Okay.
So, all right. Yeah, it just happened, if I pick a weird random number, you get 47. Yeah, if I pick 47, then it's other number. So, okay. It was a good observation. So, all right. Questions on this one? Okay. I think that's pretty straightforward. This is the concept that we're applying to all the rest of them. So again, now, the vertex gave me the first number of the pair, and then the second number was that minimum product. So that was the idea. That was the negative 100. All right, now, what I want to do now, and this is definitely a jump. What I want to go through is I want to go through one of those farm problems, with the fence line and stuff. I think we did one yesterday where we did a garden problem yesterday too, correct? Or is that must have been a later section, so they did a garden problem. But so we did a farm problem. I'm going to show you like the level of difficulty we can get for a problem like that. So let me show you one of these. Right, so this problem is radically different than the barn problem we did yesterday because of the way what they're going to ask for. Okay. So we're making a rectangular playground, so think about that, rectangular playground. And it's going to be fenced off, so you think we have to put fences on all 4 sides. Plus, we're going to divide the actual playground into 2. So putting a fence in the middle that's parallel to the one of the sides. So it's going to look something like this. So here's my rectangular playground, so things like this. And we're going to fence this off, and we're going to put a fence in the middle. So we're kind of fencing off those 2 separate halves. So way you'd ever want to do this, like if you're doing farming, you can separate different pens for animals, but they're getting the same area. A playground situation like this, where maybe you're putting like older kids on one side, younger kids on the other, that type of thing, or maybe you're putting different equipment. It's making the perfect rectangle, but dividing it into 2 halves. But we're using one fence to do it. So we're using one series of fence lines to actually make this happen. Okay, so what we're using here, if you notice, we're using 400 total feet of fence. That's it, 400 feet. 400 feet has to work all the way around, plus give me that little wall in the middle. Okay? Find the dimensions of the playground that will maximize the areas enclosed. So the maximum areas. Does that make sense? Like what we're doing here? We want the maximum area for this. Now this problem is difficult. Like if you're thinking about like the idea of what we have to do here, this is definitely tough. And we're using 400 feet of fence. So that's what I want to show you here. Okay, so let me draw this. So we're making a rectangular playground here. And we're going to try to put a wall in the middle. That's the idea. Okay, now, if we didn't have to worry about the wall right here in the middle, the fence in the middle, well, we could take dimensions. Like this could be X, this could be the other X, right? Because it's a rectangle, so those two would match. But what would the other two walls be? Okay, we are definitely going to use this 400 feet of fence, right? 400 minus the two X's divided by 2. Okay, so this is going to be 400 feet of fence minus the other two X's divided by 2. Now the reason divided by 2, there's two sides of it. We're actually using walls on both sides. So if we actually divide these both by 2, that would be 200 minus X. 200 minus X, because what I did is I took this. I took 400 minus 2X and then divided both numbers by 2. Now here's the thing. That would make sense if you're making just a rectangle, right? Just a plain rectangle. But we're not. We have that middle piece, which is harder. So here's the idea. This is where this problem changes a little bit. Instead of just subtracting, the two X's, the 400 feet minus the two X's, we actually have 3 X's. Does that make sense now? We have that third X in the middle. That is the same fence as this one and that one. So our difference here is this. We're taking 400 feet of fence minus the 3 X's, and we're dividing it by 2. There's 2 sides to this. This is where it gets a little ugly. Okay? So if I'm going to actually divide these, this actually turns out to be 200 minus, and what's 3 divided by 2? 1.5x. That's my dimensions for this wall here and this wall. So this is 200 minus 1.5x. Okay, does that make sense now? Like what I'm doing there? This is a problem that I definitely didn't show you yesterday. It's a little more difficult because we're throwing that extra wall in there. We're not putting it like, we're not using a barn for one side. So we have to think about we have 2 walls there, so we're dividing by 2. Okay, questions with how I just set that problem up? All right, so now the idea here is we're going to try to find the maximum area of this playground. So the reason why I had this set up and why I had to draw that is how do you find area for rectangle? Length and width. Well, the length of this particular problem, just so you see this, in fact, I'm going to draw this over here just so you can have this. This is X, that's X, this is X, this is 200 minus 1.5x, and that's the same over here. So the dimensions of this is the X by 200 minus 1.5x. That's the dimensions of the entire playground. Now I know there's a fence going through the middle of it, but that's the dimensions, right? The outer dimensions. So if I multiply those together, that'll be my function. That's the area that I need. Now you could do that. You could be that person maybe who wants to find just one area. So if you find just this little thing, you take this number and divide it by 2 because it'll be perfectly half. Right? So I divide this by 2 again, and that would be this dimension. So I have X by whatever that smaller number is. So you can find each pin by themselves. Well, what I'm going to do is I'm going to find the overall area, and then later on I'm going to divide that by 2 once I figure out the dimension. Okay, but does everyone understand the setup here? I'm finding the area, length times width. The dimensions were the hard ones. That's what you had to find. Okay, so actually distributing here, I have y equals 200x minus 1.5x squared. Okay, and then we're going to actually simplify this. Let's see. Any one of you want to go from this round to perfect. Okay, so let's work through this. Let's work through this problem here. Okay, so I'm going to rearrange this problem, right? So move the negative 1.5 up to the front, the 200 in the back. I don't need to bring anything across with the y because there's no problem there. But now, is there a number in front of my x squared? I have to factor that out. So I'm going to have to take out the negative 1.5 out front. So if I do that, this turns out to be x squared because I'm dividing that out. And what's 200 divided by a negative 1.5? That's what I need to know on a calculator. I know it's going to be negative.
Negative 133.3 repeats.
Okay, 133.3. We'll just kind of round it to that. I know this is going to be, if I want to make it accurate, I put that as 1/3 instead, but we'll kind of write like this. Okay, and if you want to make it super accurate, make it a fraction, 133 and 1/3. Now, I'm going to take half the middle and square it. So 133.3 and half squared, what is that number? We're just going to do decimals.
I don't know. I got half of it. I've got negative 66.6.
Okay. Now square it. So
Negative 66. It says that it's 4,440. I don't know.
is that right? That's 442. So it's like that. Okay. Point what? Okay. So that's taking half the middle, which is 66.6, right? And then taking square root, multiplying them all itself. Okay? And now we got to take this number times the number out front, so it'll be negative now. And that's what we're going to put up there. So 4,442.2 times negative 1.5.
Negative 6,653.
Okay, good so far. I know it's weird we're using decimals, but again, they want the approximate, the approximate dimensions. I can get super exact. If I want to make these fractions, I can get super exact on that. I'm just going to get kind of a ballpark where we're going here. So factoring this right side, this is x minus 66.6, because that's the 133.3 cut half, right? Squared. Right. That was 133.3 cut half, so 66.6. Yep. Okay. And on the other side, we have y minus 6,663.3. And now, what's my vertex on this particular problem now? So 66.6. 63.3. So this is your x dimension for my problem up here. That's my dimension here. These are all 66 feet for fence. And then this is the maximum area of this entire playground. 6,000 feet, feet squared. Almost 7,000 feet squared. It's a big playground. Think about it. It's 66 feet long. So that's a pretty big number here. 66.6 feet. And if I want to figure out the other dimension, because that's kind of one of the questions, I plug in 66 feet here. So that's 200 minus the 1.5 from 66. So we take 66.6 times 1.5. 99.9. So if I actually subtract this, I get like 100.1. So roughly the dimensions are about 66 feet by 100 feet, roughly. Guesstimate roughly what they are. It's a pretty big playground. And if I cut that in half, that means this will be 50 feet and 50 feet, roughly. And this is 66. Now, what makes this problem so difficult? Obviously, number one, we have a ton of decimals, understandable. But it's that weird wall in the middle. It's not just taking whatever's left on the fence and dividing by 2, but having 3 of those fences. So it's taking the 400 feet of fence minus the 3 x's and then dividing in half, which is goofy. Okay, now here's my question to you. Do you want to do another problem with like a fence? Do you want to do a problem where we have a business and we increase the price on the product or decrease the price on the product? What do you want to see for a story problem? That's up to you. So I can give you one of each, or maybe you think you're comfortable with that. Okay. All right. We'll see kind of how you do here. So here's this. That's not business problem. All right. Nah.
No homework for my
Background, I guess that's already.
Hey, look, there it is. Here's your homework today. It's actually 11 problems, but the good news is I may have done more than 4 or 5 of them. So if you're paying attention to me, I may have done quite a bit. So, this is not due Wednesday. Sorry, I accidentally typed in today's date. I'm making this assignment due on Friday. I know it's a weird turnaround, it's like crazy. Well, I'm going to do Friday. Yes, Friday. Select view, I'm not doing probably more than half of those on the board. So, you should have a few left. They're really nothing difficult. There's nothing like crazy that you're going to get that you cannot be prepared for. We'll talk about maybe 1 or 2 problems throughout the week, but they are due Friday at some point on Friday. Okay, makes sense? Okay. So you're loose, you can move around, you can sit wherever you like. I think you have about 13 minutes. I think we're out here 13 minutes. 14.
I don't got mine.
What?
Are you moving?
Bruh. You on the back? Whatever.
See ya.
I did, book.
Ready?
Oh, here you
So I'm like, okay, I'll just take the L right now and then redo it and then So.
I guess, I was like,
How about you go to boy? Well, I'm moving over there. Boy.
Here's that little model that we picked up one day.
Oh, shoot.
Connor.
Vocab. And then vocab test is next Tuesday. I know, I thought it was your like, alright. And then we check those. She's in a mood today. Like,
I know. We had a party second period. And then she'd been in a good mood sitting there. She's like, I can take an assignment if you want. She was talking to this channel. The book was on her phone. We were having a party. And she was telling us she could make an assignment if she wanted. We were like, we're having a party. We're going to see our phones. But who are rules and I follow them.
yeah, we walked into class and she's like,
Alright, hey, you gotta get to work. You didn't finish your last one.
yeah, I'm going on. Alright, very good. No.
No.
I'll be going, shall we? Come on. Yeah.
You're finding a product, you want to do,
Oh.
or when you're finding a different quiz.
Yeah, I'm moving your stuff.
That's cool.
Okay, Clevenger, at some point we gotta make you take that chapter 1 test. At some point, you got a little long. Okay, alright. So, and then Spencer, make sure you're sticking around after school to work on that homework stuff.
She just done. We have to answer pretty much.
It'd be 12 and negative 144.
So what's the
Negative 144. Maybe the weight. I don't know though, 'cause my parents have something called I took the Alfred Edwards. Huh?
No, this is just for the knowledge. If we had to do one area, answering the whole thing, we would have already done it too. So it's Yep.
The add 600 of those that what? The add 600 of those then.
I have y equals 6.
He posts like 30 pictures a day, so I'm like, no, I'm tired of seeing your face.
Differ by 20.
She's not good.
I have 300 and 150, 150 times 150.
And it was against the bond, correct? River, yeah.
22,500.
600 minus
have around 300.
Because we had 6 people together. That's 150. That's 150. 45,000. Square. What?
Actually, I have my Xbox.
Yeah, but then
I don't know. It's gonna freaking. I don't even know. At least I have it. Bring it to the library every day. No, but yeah, I was figuring out process of car would only be $25 phones to pay off for the SM $100 a month plus, let's say 60 for the plan. That's only 80, but I round it to 110 for some reason. That's still left.
I just realized you guys are listening.
That red sheet?
Yeah.
You don't even go over it. See that recycling bin back
I
there?
work every day at Rudy's. Supper's got me covered. I get a free meal plan at school because I can make less than.
I don't.
I get free meals from school, and I don't even get breakfast in the first place, so I'm good.
She says one thing.
After
Just in case, I'm gonna make
Your
money.
parents do you can say.
No, it was like aiming at like
It's like
half mad, half sad.
She has mood swings too.
Once I say that, I'm like,
You better start knocking on the door.
It's one day that she hated me.
Girl, what?
See,
No,
that's
Kate.
just it, like, if I get find someone's house to just
I just
bomb
know
out,
they made it
that'd be
for
great.
a
No one's gonna
just in
take
case.
it.
Yesterday.
Oh yeah.
So they had to take 20%.
I know Dimitri wants to move out. He's 18.
Well,
Easy. I just bumped him